Hi Madrona students, I have another geometry lesson for you today. This one is called Area of a Pentagon. If you have already explored area of a rectangle, triangle, trapezoid, and rhombus, then this lesson is for you. I've brought the materials over to remind us how we found area of a rectangle. Remember with the yellow material, we discovered that to find the area of a rectangle, you need to take the base of the rectangle and multiply it by the height of the rectangle, and you can find the area of any rectangle. And when we explored area of shapes such as the triangle, we used equivalent triangles to rectangles to derive the formula. Remember, we found that you could multiply the base times half of the height to find the area of any triangle. We did the same exploration with trapezoid, taking trapezoids that were equivalent, taking broken pieces and finding a rectangle that was equivalent and using that base formula to derive the formula for a trapezoid. We did the same thing for a rhombus. We had a rectangle, we had a rhombus, and we found the area by using the area of a rectangle to help us. We're going to do the same thing with area of a pentagon today. I don't have an inset with a space for a rectangle so that this broken pentagon can fit in it, but you know what? We're going to use a made material that you can recreate at home. This is very exciting. So here's how we're going to do it. I've taken this pentagon and I've made a paper pentagon that's left whole, one that's cut into 5 pieces, and another one that's cut first into 5 pieces, and then another piece that's cut once more. I'll talk to you about why we cut it this way. But first, let's review the parts of a pentagon. So a pentagon, you know, has sides, 5 of them to be exact, and all of these sides added up together make the pentagon's perimeter. This knob marks the center of the pentagon. You can see that. Another important part of the pentagon, I will show you with this divided pentagon. So each of these pieces is created when the vertex is bisected or cut in half. So these are the angles of the pentagon or the vertices of the pentagon. And so I'm going to remove this piece and try and show you. You have to use your imagination. If there were to be a line going from the center to the midpoint of one of the sides, any one of the sides, it would be called an apothem. You probably saw this with the box of sticks where we labeled polygons and had apothems coming from the center to the midpoint of one side. That's important to know, so let's keep that in mind. So when I created the cardstock area material for Pentagon, I traced this whole piece, and then I traced 2 more, as I showed you before, that are equivalent. So I just traced the pentagon 3 times, but 2 of them I cut into pieces so that it could help me think about area of a pentagon. So this purple one that's divided, I just use these smaller pieces to help me know exactly where to cut those pieces. And then when it came to cutting this one, I wanted to make sure I had a piece that showed the apothem. So remember I said the apothem goes from the center of the pentagon to the midpoint of the side? Just cut that piece exactly in half. Okay, these 2 are going to help me derive the formula for area of a pentagon. Just like all of our other shapes, we're going to remember the rectangle, and we're going to remember the rectangle's formula for area. Super simple, base times height, right? Okay, here's my pentagon. I want to find the area of this pentagon. I'm going to take the one that's divided into just 5 pieces. Now remember the important parts of a pentagon, right? We have all of the sides, we have our center, we have our apothem. So I'm going to take my pentagon, let me back up so you can see, and watch what part of the pentagon becomes which part of my rectangle. Okay, so I've used up all the pieces of the broken pentagon, all 5 of them, right? What part of the rectangle did that become? You can say it out loud to yourself. We'll see if we match our ideas. I'm going to take the broken pentagon and fill in the top of the rectangle. Okay. I almost have a rectangle, but I have a little space here and a little space here. Guess which pieces are going to fill those in? I have this last piece that was cut along the apothem, right? So it makes the right angle, the apothem. I'm going to take this piece, and it looks like it fits right there. And this piece perfectly fits right there. Okay, so now we have our rectangle. The base of the rectangle was which part of the pentagon? Let's keep in mind we used 2 pentagons to make this rectangle. So our area of a pentagon formula will have to start with 1/2 of whatever we end up writing down as our derived formula. So let me just keep track of this. So we have area of a pentagon. If we want to find the area of one pentagon, we have to remember we're taking 1/2 of whatever the area is here. So the base of this rectangle came from all of the sides of one of the pentagons, which is also known as the perimeter. I'm going to use a P to represent perimeter of a pentagon. And then we need to multiply it by the height. And what did the height of this rectangle come from? Remember that special name? Apothem. Okay, I'm going to write A for apothem. So to find the area of a pentagon, you take 1/2 times the perimeter times the apothem. Now, I have not measured the sides or the apothem to this pentagon because I'm hoping that you will use this material, perhaps measure the apothem, measure the sides, and see if you can find out what the area of this pentagon is using this method. I can't wait to hear what you come up with. I recommend using the metric side of your ruler just because a lot of these Montessori materials are made to centimeter or millimeter specifications. So start with that side and then let me know what you get for your answer, and you can explore any pentagons that you might have in your house. You can also make larger pentagons or smaller pentagons using this one. All you need is a compass. So if you want to have a lesson on how to make more pentagons using this one with a compass, I can show you how to do that. But for now, take this material, cut it out, and explore. I will leave copies of this material for you to cut out in the parent mailbox at school. Just let me know that you're interested and I'll make sure there's a copy for you to pick up on Monday. Have fun.